Composite function. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. You will learn how to combine two functions to get a new function. A very important way of combining two functions to obtain a new function is to create a composition of functions to obtain a composite function. It looks weird at first, but it isn't. Let's see how it works. Suppose f of x is square root of x and g of x is 2x plus 1. Find g of 4. 4 belongs to the domain of the function g. Replacing x with 4, we get 9. The number 9 belongs to the range of the function g. Now find f of 9. The number 9 belongs to the domain of function f. Replacing x with 9, we get 3. The number 3 belongs to the range of a function f. Now let's see what is happening. G of x is a function which maps a to b. And f of x is another function which maps b to c. Now let's think a little bit. Could we get a function that maps a to c directly? The mapping of elements of a to c is the basic concept of composition of functions. When two functions combine in a way that the output of one function becomes the input of another, the function is a composite function. The composite function is made up of the functions f and g in an interesting way. The composite function of f and g is written as: it's read f composed with g of x. I prefer write in this way when I work with composite function. I usually write the expression to the more intuitive form. This is not required, but I certainly find it helpful because composite function works from the right to the left. This means that given a number x, we first apply the function g to it. G is the row multiplied 2 by x, then add 1. Now apply f to the result. In this case, f is the row. Take the square root. The f composed with g is the row multiplied by 2, then add 1, then take the square root. Let's see if it works. Rewrite the composite function to the more intuitive form. Remember that composite function works from the right to the left. F composed with g of 4 is f of 9. And f of 9 is the square root of 9. When dealing with composite function, we always start working from right to left. Don't forget it. Giving f of x equals to x plus 3 and g of x equals minus x plus 5, find fog of x. Start by rewriting the notation to be more intuitive. Replace g of x with minus x plus 5 in the composition. This will clearly show us the order of the substitutions that will need to be made. Now substitute the expression minus x plus 5 into function f in place of its x value and perform any needed simplifications. Find gof of x. Start by rewrite the notation to be more intuitive. Replace f of x with 2x plus 3 in the composition. Remember, we always start working from right to left. Now substitute the expression 2x plus 3 into function g in place of its x value and perform any needed simplifications. Gof of 3. We already have the expression of the function g composed with f. So just take that expression and replace x with 3 and perform these calculations. Giving f of x equals x squared minus 2x and g of x equals 3x plus 2, find fog of x. Start by rewriting the notation to be more intuitive. Replace g of x with 3x plus 2 in the composition. Now look at the function f, and whenever we see x, we replace x with 3x plus 2 and perform any needed simplifications. Find g composed with f. Start by rewriting the notation to be more intuitive. Replace f of x with x squared minus 2x in the composition. Now look at the function g, and whenever we see x, we replace x with x squared minus 2x and perform any needed simplifications. Find fog of 2. We already have the expression of the function f composed with g. So just take that expression and replace x with 2 and perform the calculations. Domain of composite function. The domain of the composite of two functions depends on the domain of the original functions. This is due to the fact that the domain of g is in the domain of f composed with g, and the range of function g is in the domain of function f. In other words, f composed with g is defined whenever g and f are defined. Let's see how it works. Given f of x and g of x, find f composed with g. Start by rewriting the notation to be more intuitive. Replace g of x with its expression in the composition and look at the function f. Whenever we see x, we replace x with 1 over 3x plus 2 and perform any needed simplifications. To find the domain of f composed with g, we first must find the domain of function g. The domain of function g is all real numbers except minus 2 over 3, since this value creates a zero denominator. Therefore, the composite function also cannot pick up this value of x. Now let's find the domain of function f. The domain of function f is all real numbers except 2. And we know that the range of function g is the domain of function f. See the diagram on the left. Therefore, we need to exclude from the range of g that value of x for which g of x equals 2. Set g equals 2 and perform any simplifications. In short, since the value of minus 1 over 2 will create an answer of 2 from function g of x, and we know that 2 cannot be picked up by f of x, the value x equals minus 0.5 must be excluded from the domain of the composite function. The domain of f composed with g is all real numbers except minus 2 over 3 and minus 1 over 2.